Also, the objective that we'll touch base upon is like the syllabus part of the derivative, which is maxima minima. And as the name itself suggests, that when you talk about the derivative and maxima minima, it is obviously linked with the slope concept once again. So now, for example, let's say if I have a graph, let's say the graph is something like this. And now what I'm going to do is I'm going to use the basic concept of the slope to find out these coordinates. These are called as maximum or minimum, or sometimes also referred as stationary points. Now, before I start with this, I want to just introduce some of the key terms. Number one is when you talk about the slope, as slope indicates the whether the function is increasing or decreasing. Now, slope is basically nothing but dy by dx expression. Now, remember that wherever the slope is positive, like wherever the slope is positive, it means that in that case, the function is increasing. So it means that it's like you're climbing a mountain. In case where the slope is zero, I mean dy by dx is less than zero, you're falling down. So for example, if I look at the current expression, I mean current graph, here you can see in this range, the graph has a positive slope. Also out here. So wherever the graph has positive slope, we call it as increasing. And wherever it has got negative slope, for example, here, in between this to this, it we call decreasing. Now, obviously, we can talk about a third case here, which is what if it's neither increasing? I mean, whether it is like, I mean, when it is dy by dx is zero. What about that case then? So obviously, when we talk about the slope being zero for a particular curve, as you know that this will occur out here. If I draw a tangent out here at maximum or minimum, you'll notice that the slope of these curves, which is dy by dx, is basically zero. So here dy by dx is zero, as well as here dy by dx is zero. Now this becomes one of the strategy for finding out at what coordinate or coordinates does the function have either maximum coordinate or the minimum coordinate. Now, obviously, the strategy is that to find out, because not every time you'll be given the graph, and find out and verify. So let us first take an example, a simple quadratic, which we can relate. So let's say y equals to x squared minus 3x plus 2. Using calculus, like we used to do the vertex, I mean, using normal vertex formula, which is x is negative b over 2a, we used to do the minimum or maximum of this quadratic. Obviously, in this case, it'll be like a minimum graph. But what I want to just see is like, assume that I don't know anything about this graph. My first intention here is to actually, I'm finding out the stationary point. Now, stationary points are the points, guys, where the slope is zero. So you will hear these words, stationary points, turning points, a maxima minima. So these mean almost the same thing. So now first thing what I'm going to do is, when they say that, find out the coordinate of stationary point, if any. It's not necessary that a curve has a stationary point. Now, if you look at any exponential graph, you can see exponential graphs doesn't have a stationary point. Or a logarithmic graph doesn't have a stationary point. So it's not necessary that each kind of graph has to have a stationary point. So let us just understand how to find out, let's say dy by dx here. So dy by dx will be 2x minus 3. Now for standard procedure is, when you want to find out the maxima or minima, you first find out the dy by dx equate to 0, solve for x. So this is the strategy number one. So solve for x. Now, when I solve for x, let's say if I equate to 0, because I know that for maxima and minima, your derivative is 0. Now equate to 0, you get x is nothing but 3 over 2. So once you got x is 3 over 2, now I'm clueless whether this point is a maximum point or a minimum point. Now, in this case, obviously, we know that it is the coefficient x squared is positive, so it'll be like a minimum. But I don't want to use those or any of those. So what I do is I will be drawing Sine diagram of single derivative. So now when I draw Sine diagram of single derivative about this point, which I got, Sine diagram of single derivative, which is, let's say, x is 3/2. And now you plug in the value here. Let's say if I take 0 here and plug in the derivative. Remember, you're drawing Sine diagram for derivative. So for example, if I take 0, so 2 times 0 minus 3 is going to be -3. So this point is negative. I mean, Sine diagram for derivative will be negative in this. And beyond 3/2, the derivative is positive. So now, if a function is first decreasing, as you can see, if a function is first decreasing, and then increasing, it's like a minimum. So remember that if the Sine diagram it changes its sign from negative to positive, it assures a minima. If Sine diagram changes from positive to negative, it's a maximum point. And this is the Sine diagram of derivative. So now, according to the current statistics, what we have got is that the derivative at x equals to 3/2 is 0, and hence we could verify that's a minimum point. Now, to get the minimum value, you're going to plug this x coordinate as 3/2 out here. So if I plug x as 3/2, it'll be 3/2 squared minus 3 times 3/2 plus 2. And this is going to be the minimum y value for the given function. So obviously you can calculate this. I'm not going to calculate. So the summary of this, what we need to do is always remember that a curve can have more than one stationary point. If it's a cubic curve or any rational curve, you can have always one or more than one stationary point. Some curves don't have, like as I showed, exponential and log functions. They just like are purely increasing or purely decreasing. So here, important thing is what we need to take care is when does the function increase? So if the word increasing comes, you will see where is the slope positive. So now you can see that in this graph up till, let's say if I take this coordinate as A and this coordinate as B. So it function was increasing until x less than or equals to A or x greater than or equals to B. And it was decreasing between A or A and B. So this is decreasing here. And as you can see, the slope is negative, and here it is increasing. Now, another question that comes in lots of students' mind is, what about why I'm including less than or equals to in both the cases? Now, if the word strictly increasing is introduced, in that case, this will be not equals to. So like straight away in that case, if it is strictly increasing, let's say if they ask, in that case, it'll be x less than A or x greater than B. And when you talk about strictly decreasing, it'll be between x between A or B, A and B. So this is how you logically interpret the maximum and minimum. But let us take one more example before we go to the next strategy, how we can alternatively decide whether the point is maximum or minimum. Now, one thing that is not explicitly mentioned in the syllabus of the additional mathematics is what if this sign doesn't change? What if the sign doesn't change? Let's take an example. What if the sign doesn't change? So let's take an example of, actually, I'll just take the next page. And here, let's take an example of y equals to x cubed plus, let's say x cubed graph. Now, when you say y equals to x cubed graph, I'll just give a little bit of background information. X cubed graph, obviously, if you try to plot it using a technology, it is something like this. This is how x cubed graph look like. Now let's try to find out what about maximum or minimum here. So let's do dy by dx, which is 3x squared, equate to 0. Solve for x, x is 0. Now what we're going to do next up is you do the double derivative. Sorry, not double derivative. Draw the Sine diagram of single derivative. So when you draw the Sine diagram of single derivative, dy by dx about 0. Now let's say this side I take -1 and plug here. So 3 times -1 squared is positive 3. So here's positive And if you take x as 1, obviously here it also is positive. So you could see here there's a little bit of contradiction. Now, why both the sides it's positive and positive? Or sometimes you'll notice that it's coming negative or negative. Now, in such cases, we use a specific term called as inflection point. Now, inflection point is basically a point around which the curve changes its concavity. Now, concavity is like here it is, you can see it's concave down. So you can see it's like sloping like this. And after that, it becomes like concave up. And for a fraction of a second here, it becomes here, if you draw a tangent, it's like not that steep, it's like this. Like, here if you draw a tangent, its slope is 0. If you try to draw a tangent here. So in such case, even though the derivative is 0 at that point, it doesn't assure it is a stationary point. Yes, it is a stationary point, but it is referred as an inflection point, not a maxima or a minima. And how do we recognize that? So when you draw the sign diagram of single derivative, you will notice that the signs don't change either side of this point of inflection, you can say. So this is just, you have to be a little careful in terms of the presentation or in terms of logical reasoning, because every time positive to negative or negative to positive, you'll not get the curves. So let us take an example, which is a math and AS level example. Let's say if you have function is, let's say y equals to x squared plus 1 by x squared. Let's say this is the function. And what I want to find out is where are the stationary points for this curve. So once again here, I don't know how does the graph look like. So I'm just going to modify this curve that I can differentiate. Now you do the dy by dx. So dy by dx will be 2x plus derivative of this is going to be negative 2 x to the power negative 3. So the derivative will be 2x minus 2 over x cubed and equal to 0. So that's the derivative function. And now what I'm going to do is, if I equate this to 2 over x cubed, cross multiply, it will become 2x to the power 4 is 2. So x to the power 4 is 1, and you get x is plus or minus 1. So the 2 points that seem like they are either maximum or minimum, let's check with the single derivative sign diagram. Now, single derivative sign diagram, if you look at here, if it is, now try to draw derivative sign diagram. So if I take, let's say 1 here, and now let us try to take, let's say maybe 2 this side. If I take 2 here and plug in this, so 2 times 2 minus 2 over 2 cube, which is going to be positive number because 4 minus 1 upon 4 will be positive. So at around 1, this is positive. And before 1, let's take 0.5 or something. You can't take 0 here. You can see that it become undefined because there's a vertical asymptote at that point. So try to take, let's say, x as 0.5. And if I plug x as 0.5 here, so it'll be 2 times 0.5, which is 1, minus 2 over 0.5 ka cube. And this value will be definitely bigger than this one because 2 over 0.5 cube, if you do, it'll be higher than this answer. So it's going to be negative. Now it's clearly showed that at 1, there is a minimum point. So because since it's like the curve is like this, it decreases and then increases after 1. And so that's why it's minimum point. And its minimum value, you'll notice, is if I plug y as 1 here, so it'll be 1 squared plus 1 over 1 squared, which is 2. So that's your y coordinate. Now still we are not done with the second part. Now to verify the second part at x equals to minus 1, you plug in, let's say, for example, negative 2. So if I plug in negative 2 once again, you'll see that this is going to be, if I plug x as negative 2 here, now 2 times negative 2, so 2 times negative 2, and minus 2 over negative 2 cube. So this will be positive answer, and a bigger chunk is negative. So this side also is becoming, let's say, negative, if I'm not wrong. And this side, on the right side, if I take, for example, 0.5, negative 0.5, here will be negative 1 plus answer. So it'll be again positive. So around this point, you'll notice that at x equals to -1, once again, there is a minimum point. So there are two minimum coordinates, which indicates that, let's say, if I take x as -1 here, once again, it will be at -1 comma 2. So this is a interesting equation because you get two minimum points. Okay, and now it'll be also interesting to see how its graph look like. So let's just try to investigate about its, like, how does the graph look like for this particular equation. So just now, if you look at the exact answer that we got in the previous part, and if we verify with the answers that we have here, you can clearly see that we got the coordinates, two minimums, and there was a vertical asymptote here, and it is decreasing here, again increasing between -1 to 0. Then from 0 to 1, it is decreasing, and then 1 onwards, it is increasing. So this is how you basically understand the concept of maximum minimum. And now let's take a strategy of an alternative way to verify without, in case if we don't want to use the Sine diagram for single derivative. So now in case if we have, let's say, the um, function and we want to use the alternate strategy for verification of maximum or minimum point. Now, for example, let's say if I have same equation which we took last one, x squared plus 1 by x squared. Now, there is this alternate strategy or pathway we can remember. Number one is step number one remains the same. Dy by dx equal to 0. Solve for x. Now, what is really interesting is that after this step, we can use the second derivative. Now, second derivative is basically if you solve for x and if you plug this answer in the second derivative expression, and if that derivative comes as positive, it is a minimum point. And if double derivative, second derivative, comes negative, it's a maximum point. So this is one of the much more comfortable technique to find out whether the point is maximum or minimum. Now, why do we call, like, why do we say, okay, double derivative is greater than 0? So now generally, just remember that for concave up, double derivative represents concavity. So concave up curves, which is like a minimum curve, double derivative is always positive here. So for any of these x values, if you plug them in second derivative, you'll notice that that answer is positive. Similarly, for concave down curves, which is like a maximum, at every point here along the curve, if you find out the value of double derivative, it'll be negative. So you find out the double derivative expression, plug these x coordinates out here, you will notice all the answers are negative. So this is a set pathway you can use to check whether the points are maximum or minimum. I'm not going to put too much time onto finding once again the derivative and all because we just did it. So dy by dx was 2x minus 2 over x cubed. And when we solved, we got x is plus or minus 1. When I equated to 0 and solved, I got x is plus or minus 1. Now, after this, we drew the Sine diagram. Rather than Sine diagram, what we can do is we can find out the second order derivative. Now, in second order derivative, if I find out the second order derivative will be d square y over dx square. It's going to be derivative of 2x. So we just modify a little bit, 2x minus 2x to the power negative 3. So derivative of 2 will be 2x will be 2 plus this derivative, I mean, put it minus first so that you don't get confused. Minus 3, 2x raised to minus 4. So 2 plus 6 over x raised to 4. Now that's your second order derivative. Now if I plug here x as 1, I can clearly see my answer is positive, which indicates that it is a minimum coordinate. If I plug x as minus 1, I also see that in that case also answer is coming as positive. So if both the answers are coming positive, it means that there are two minimums. And of course, if you want to find out their values, y values, you plug in the main equation to get the y value. So this is just in short how you find out the derivative, how to use double derivative. Let's take one more example about the same. So now let's take an example where we basically have to find out and verify the maximum or minimum coordinate using the second derivative test. Now, one of the favorite question additional mathematics or AS level examination, like for example, let's say if I have x cubed minus 6x squared plus 3. Now suppose this is my function and I want to find out what are the coordinates of maximums and minimums, if any. Now our steps are going to be that you find out the dy by dx equate to 0. Now when you find out dy by dx, it's going to be 3x squared minus 12x plus 0 equate to 0, because derivative of x cubed is 3x squared minus 6x squared derivative is minus 12x plus 3 equals to 0. So now after this, what we do is take 3x squared minus 12x equals to 0. So take 3x common and you get x minus 4 equals to 0. So you get 2 points, is x is 0 or x is 4. So you got 2 points where possibly the graph has a maximum or minimum. Now, question further might be asked is like, okay, find out the double derivative expression. So when you find out the double derivative expression, so first thing is use the double derivative test to check which ones are maximum or minimum. So you first find out an expression for it. So second derivative will be derivative x squared, 3x squared will be 6x minus 12. Now you plug x as 0 here. So if I take x as 0, my double derivative at x equals to 0 will be 6 times 0 minus 12, which is negative 12. Since we just learned that if your double derivative is negative, you can clearly see that it's maximum. So there, when x is 0, my double derivative is negative, which indicates maximum at x equals to 0. And what is this y coordinate? So if I plug x as 0 here, you get the y coordinate will be 0 cubed minus 6 times 0 plus 3, which comes down to answer as 3. Now coming back to the second coordinate, if I plug x as 4, so if I plug x as 4 here, so you notice that it's 6 times 4 minus 12, which is coming as positive, because which is greater than 0. So double derivative when x is 4, is coming as positive. So it is a minimum point, because if you see here, when double derivative is positive, it's a minimum. If double derivative is negative, it is a maximum. To get the y coordinate, you're going to plug x coordinate here. So it'll be 4 cubed minus 6 times 4 squared plus 3. So which is like 64 minus 16 times 6 and plus 3. So whatever the value that comes, you got to simplify that. And so that's your y value. So that's how you use single derivative, double derivative concepts to find out the maxima and minima for a particular given function.